My name is Ira Chowdhury. I'm on the digital page team, and I'd like to welcome you all to this session on machine learning in AWS using SageMaker. If you have a question, please reach out to an admin on Discord. One of us will make sure to get to your questions during our audience Q&A. And before we begin, I would just like to take a moment to introduce our speaker, Hemant Sharma. Hemant is the Senior Partner Solutions Architect at AWS. He has 18 years of IT experience in iCloud computing, web applications, solutions architecture, and cutting-edge technology like machine learning. So thank you again for joining us. And with that, I will pass it off to Hemant.
Yeah, thanks, Ira. Thanks for the introduction. And good evening, good afternoon, everyone. Thanks for joining the session. And let me start sharing my screen, and do let me know if you are able to see my screen. 1 second. So hopefully you will be able to see my presentation in the full mode.
Yes.
Okay, great. So thanks everyone. So I'm Hemant Sharma. I'm working as a senior partner solution architect from AWS. And in today's session, I'll be going through all the different options Amazon provides in the AI ML space. The list is quite huge, but today we'll be focusing on SageMaker, which is kind of like our managed AI ML service for you. And we will see some of the crucial components. And in the end, I'll also take you through a demo on how we basically do it using the Amazon SageMaker Studio. So with that, let's start on today's session. Yeah. So yeah, it looks like a quite heavy deck, but if you look at this is the basically AWS AML stack, right? So there are mainly 3 layers which we provide. If you look at the first layer, AI services, these are kind of like our plug and play service, right? They do cater across different industry use cases. Like if you are coming from financial industry, then we have Amazon Forecast as well as the Amazon Fraud Detector services. And if you are coming from, a typical chatbot and speech sort of NLP background, then we have services called Amazon Track, Comprehend, Poly, right, and Amazon Lax, which is our chatbot offering. So the very first layer is think of these as like pre-built SaaS AI services for you. You simply come up with your set of data and you use that data to train your model. And then once your model gets trained, automatically you can calling the API for the deployed model for you. So if your business use case fits among all the different pre-built AI services, then you should pretty much free to use. Uh, Obviously, you will be charged, but you can use any of these AI services. The middle layer is what we are going to talk today is Amazon SageMaker. So Amazon SageMaker is AWS offering for it's a managed service for all your machine learning requirement, right? So like a typical machine learning MLOps pipeline has many steps, right? The very first thing you need to, if it is a supervised learning, you need to kind of like label your data, right? So data itself might be can of hundreds of GVs or more than that, right? So if you're going with a manual route to label your data, it might take months, if not years, right? So right from that, once you gather your data, then basically the next step is that you start cleaning the data, validating the data, enriching your data, do a lot of feature engineering, right? So if you have done any of the machine learning workflow process, you know that as a part of feature engineering, you fill up all the missing columns, you clean all the rows and create new additional columns, you do correlation and variance activity against your target feature. and then you try to clean your data so that it can be fed to the machine learning model, right? So that training can be done. And once you feed your machine your data to your algorithm to train your model, obviously it's not a one-time job, right? Potentially you might run thousands of experiments with different parameters and hyperparameter uh, uh, variables to come up with the best model for your business problem which you want to solve with the machine learning. And that itself is not also not one time job. Suppose if you come up with your machine learning model today, tomorrow again, based on the ever changing landscape of data and the design pattern of the machine learning model, you again need to retrain your model. So again, you go through the entire process and run hundreds or thousands of experiments. So the whole thing is quite iterative in nature, right? And then while training your model, you need to debug your model, you need to deploy that model and do a preview, and also need to check that there is no biases in your model. And then once you deploy your model, you need to keep on monitoring that model. And if the prediction goes south, if there are some degrade in your prediction, then again you need to retrain. So there is a whole bunch of MLOps pipeline, which if you go and try to do yourself, it can take a lot of time, effort, money, and you also might not achieve the best possible thing which you want to provide for your businesses, right? So in order to address that entire end-to-end ML pipeline, the SageMaker is the AWS services, and under this service, you will see that there are many components which try to address all these different phases of the machine learning MLOps pipeline, which you'll be seeing today. The last but not the least, so these are our core framework and infrastructure offering. So think of a scenario that in your team is more keen to get our high processing GPUs combined with all the machine learning framework like TensorFlow, PyTorch, MXNet, and many others which we provide as part of our offering under this IS layer. So we provide all those GPU, high power GPU based capability along with all those frameworks. So if you are interested in that, you can just avail those deep learning AMIs, containers, and instances, and you can start creating your own machine learning MLOps pipeline. So for different needs, we have different offering to all the people who are either starting or very deep into their machine learning journey. And today we are going to focus on the Amazon SageMaker. So I think I talk about the development cycle of a machine learning, and as I told you, it's quite complex. Again, to rephrase the point, starting from labeling the data, right? It might take ages, and then once you label it, you collect it from different sources, you do feature engineering, you prepare your data, and then it's not only your team who's working on the data. There might be other teams in your enterprises who will be working on their set of data. They also go through the same pipeline, and then they try to come up with a feature store, right? So all the features on which you train your machine learning model as an enterprise, you want to make a single source of truth for all the features on which the models will be trained. So for that also, Amazon provides a feature store, which we'll be touching base today. And then while training your model, you need to make sure that there are no biases in your model, right? So think of a scenario that you're going to prepare your model for a financial industry who's going to approve or deny a loan for a particular person based on the machine learning model. But your model is kind of like got trained on a data which itself is a bias, right? So if suppose for training your model which will predict whether a loan should be given to this person or not, you train your model onto a data which only contains specific age group of data, right? So like 25 to 45. So obviously, in the real-time scenario, if a person of age 55, if he's applying for a loan, because your model got trained on the wrong data set or a biased data set, not a wrong data set, obviously the model prediction will be biased. So all this kind of thing also you need to make sure that you are addressing. And then during the machine learning model MLOps pipeline, you do a lot of visualization, you do a lot of analysis, right? So that is also a big part of your machine learning model deployment journey. And then another big thing is that which algorithm to pick, right? So getting data, cleansing data is one thing, but you also need to make sure that you pick your algorithm wisely, right? So many times biases might be introduced if you pick a very simple algorithm, but with a huge data set, or if your data set is small and your algorithm is quite complex. There are a lot of moving parts which can impact your performance of your model. So you need to pick your algorithm very, very wisely, right? And then at the time of training your data, this again altogether different ball game. You probably want to run thousands of experiments with different parameters. You want to right tune your parameters and then make sure that model is not biased, or it will behave uh, uh, acceptably well in the real time scenario. So you do a lot of hyperparameter tuning. So that also is another challenge while running your MLOps pipeline. And then once you come up with your best model, then deployment is again a challenge that once you deploy a model, it can be a real time or it can be a batch processing model. So in a real time deployment, you have to make sure that if the workload increases uh, for the prediction data, your model should be deployed behind a scalable manner that it can scale up, scale down. And then obviously after deployment also you need to monitor your model so that if the performance degrades, you again need to retrain. And in order to retrain again, you need to embed CI/CD. So this is so many moving components. If you try to develop it on yourself, before even you roll out your first model, it might take months, if not years, to come up with everything on your own. So SageMaker basically provides all the different services you will see shortly. Uh, um, the major one will be covering in today's call. But in nutshell, SageMaker is a service which has answer to all these moving parts in a managed service, right? So you just provide the configuration, you set up, you provide the scripts, or you provide your data, and in the backend, this managed service will do everything for you. So let's move on. So these are some of the components or services under the SageMaker service, which basically caters all these different moving components into your MLOps journey, right? From labeling the data till deploying the data and monitoring your deploying the model, monitoring your model, and generating the machine learning pipeline. So everything is embedded into SageMaker. So I won't go through the entire list, but let me quickly touch all the columns. So the very first column or phase of your machine learning journey is prepare, right? So whatever data you have, if it is a supervised learning, you need to label your data. So for that we have SageMaker ground truth, and I'll be touching base upon later today. And then once you get your data, the data feature engineering part takes around, I think, most of the time, right? For data scientists and data engineers. So SageMaker Data Wrangler is our visual editor tool. Using that, you can it provides you pre-built transformation and analysis frameworks or functions which you can use inside this visual editor, which I'll be showing you. So you can create a pipeline to clean your data, to validate your data, to analyze and transform your data, and enrich your data, which eventually you will use to train your data, right? And then SageMaker processing is again used to run any sort of processing job, which will be touching base. Feature store to store your features and clarify to make sure that there are no biases in this model. So that is under the prepare, and then comes the build. So within build, you will see there is a very good uh, uh, ML IDE called SageMaker Studio, and you do all your activities on the Data Studio, which I'll be showing you in a moment. And inside that you have your notebooks. You can write entire your code, and you will see that you can use our inbuilt provided algorithm, or you can also use the popular framework which we provide, like MXNet, PyTorch, TensorFlow, etc. Or if you have deployed your model already somewhere else, you can simply bring your model and we can deploy it. And just to let you know that in the backend, everything runs as a container, right? So whatever model you come up with, you just need to create an image out of it, and then that image will be downloaded and it will run as a container. I'll be touching base upon on that part. So that is build, and then for train and tune, we have entire thing is a managed training, right? So you will see that for training, SageMaker will create a cluster for you based on the number of EC2 instance you define that. So think of a scenario. You'll simply write 2 lines of code telling SageMaker that, okay, create a training cluster for me and spin off these many number of EC2 instances of this type and with this EBS volume and other configuration parameter. And in the backend, uh, uh, it will create the cluster for you. The training will happen, and as soon as the training is finished, the cluster will be torn apart for you, so that you only pay for the time you are using other training cluster, right? And inbuilt, if you are running thousands of experiments, that is also totally managed for you. For each experiment, the data will be compared, the confusion metrics or whatever metrics you are after, that will be compared, and the batch model can be deployed. And then for deploying also, we provide you a managed service. Again, you write couple of line of code and you can deploy your model in real time, or in a serverless, or in asynchronous, or in a batch fashion. So there are a lot of flavors available based on your need, and the entire thing is totally managed for you. And then the model monitor is there, which will make sure that after deployment you keep an eye on your model, you make sure that the performance is not getting degraded. So the entire thing is totally managed for you, and the SageMaker is kind of like a service, and under that service all these different service or component sits, who basically takes care of your uh, all the pain points you go through for deploying your own MLOps pipeline. So this is the beauty of the SageMaker, that it does all the uh, undifferentiated heavy lifting for you, and you only focuses on the main part of getting your data, enriching your data, and making sure that the best model is getting deployed. Now, this is, I'm trying to segregate this journey, the same journey which you saw in the last stack. So in this stack, we will go through under each section, and we'll try to cover some of the main services which falls under a different section, and how they solve your problem in a managed way, so that you only need to focus on your business part or the core data science part. So let's look at the left hand section is collect and prepare training data. So what different services help you to label your data, to collect your data, and then do data cleansing, data transformation, and initial EDA, the exploratory data analysis or other sort of analysis, right? For that also you write a lot of NumPy, Panda, or different framework scripts, right? So everything you will see has been embedded for you, and you just need to utilize those managed part. And same thing goes for other section also, like for choose or bring your own machine learning algorithm. We provide, I think if I'm not wrong, around 2022 inbuilt popular algorithms, right? Like for XGBoost also, I think we have for fraud uh, uh, time series analysis also we have. So I'll be touching base upon all those. So not only we provide inbuilt algorithm for you, but on top of those algorithm, we also provide popular framework like PyTorch, MXNet, TensorFlow, chaining, and so on and so forth. So if you want to use our algorithm, feel free to use that. If you want to use popular frameworks, feel free to use that, or none of the above. If you want to bring your own model, you're also free to do that. That we'll be seeing today. And then in the third and fourth section, again, these how to set up and manage environments for training. I'll be showing you how the cluster works in the backend, and you only pay for what you use. And there are inbuilt debugger. So while training, you can keep an eye on, what the coefficients being getting generated, so that you just don't wait till the end. If your model training is going south, you'll come to know much earlier because you are using model debugger. So all these things are there. So let's go one by one. So the very first thing, uh, it's an end-to-end solution for you. I think I try to portray the same picture. Is that there is a single spot which I'll be showing in a second. So I'll be keep on switching between the demo and the PPT. So using the SageMaker Studio, that's our uh, uh, cloud-based machine learning ID just for running all your end-to-end machine learning pipeline and projects. So inside that, you will see that how easy it is to spin off your notebooks, how easy you are creating your training cluster. You will see that inside those notebooks, we provide SageMaker SDKs and Python and libraries that are abstract, that abstracts away all the low level APIs or all the low level functions for you. So like, for example, I was telling you, you simply write two line of code to train your model, and that two line of code in the backend will create the entire cluster for you. The distributed training will happen, and then once the model artifacts get generated, your cluster will be torn apart. And same thing goes for deploying your model. You just simply write one line of code and the model will be deployed for you. But in the backend, a lot of things happen, but you don't need to worry about that. You simply use our SageMaker Python SDK or Voto 3, whatever works for you, and then you create this entire thing for you. The other thing is entire thing is very cost effective, right? So while, so if you think of a scenario that if you try and go label your data yourself, it might take ages and a lot of manual cost will occur to you. But using our ground truth inbuilt, it uses machine learning capability that it can automatically label your data. So that saves you cost. And while training also, you can simply use our EC2 spot instances that will also save you cost. So, and the inbuilt security is that the entire thing you can deploy under the VPC, you can make sure that it is not publicly accessible. So all the inbuilt feature makes it quite cost effective, secure, and it is DevOps ready as the inbuilt CI/CD pipeline is part of the SageMaker Studio. So let's look at some of the key features. So the very first thing is the SageMaker Studio, right? So think of a SageMaker Studio. Let me show you. So this is SageMaker Studio. Hopefully you are able to, yeah. So let me show you. So if you go to the SageMaker, this is the SageMaker uh, console in AWS Cloud, and here comes the studio, right? So you can simply go and launch your SageMaker Studio. So once you launch it, this is the SageMaker Studio. So you can see it's a cloud-based ID, and inside this ID, you can spin off all these Jupyter notebooks and all the components which I showed you. You can see that all these components are listed here, like the data wrangler, which I'll be talking, the feature store, the pipelines, the experiments. I told you that you might run thousands of experiments and trials, right? So, and once you create your model, you need to register your model. So model registry is there, and endpoints once you create, and you need to deploy your endpoints. So all these different components are embedded into this SageMaker Studio. And the good thing is that you can even share your space with other colleagues. So suppose if I'm working on this particular notebook, right? So I can simply go and share this notebook to one of my another data engineer or data scientist who's working with me, right? And it comes with this uh, all the notebooks. You can choose different kernels and different frameworks, and you can write entire code in this notebooks. And I'll be showing you there are inbuilt SageMaker Python SDK, like in this case I'm showing you here, this solves a lot of your problem. Later I'll be showing you how using this abstract API call through this SageMaker SDK, it solves a lot of your problem. But at this point, you can just take away from this part is that SageMaker Studio is online machine learning IDE to collaborate with your users, and you can an entire end-to-end machine learning pipeline here as all the different components are already embedded into this and they are pre-built integrated with each other, right? So that's Studio, SageMaker Studio for you. Now let me go back to my original slide. So as I told you, the SageMaker Studio is the single place where you can collaborate with your team at scale. You can run thousands of experiments. All those experiments results will get stored for you. You can go and compare it in a graphical manner, and automatically the best model can be deployed in the model registry first, and then if you are going SageMaker pipeline, then if once approved, it will automatically deploy it as an endpoint for you. So the entire thing is quite seamless, pre-built, integrated, and you don't waste your time on setting up all this undifferentiated heavy lifting, right? So it basically increases your productivity because everything is as a managed service for you. Now, I think I covered this part, so I won't spend much time. The same message that you can work as a team, you can share your data, you can use the inbuilt component which are part of Studio to create the entire MLOps pipeline. So this is a screenshot, like on the left hand side, you can see that, while uh, creating or doing the exploratory data analysis, uh, you can run thousands of experiments, and on the right hand side, you are seeing comparison of these different experiments, right? So how each model is doing against each other. So everything is pre-built for you, and that really helps, right? Because at the time of generating your model, training your model, you would like to do a visual analysis of how model training is going on. So that's pretty much inbuilt into the SageMaker Studio. And as I told you, there is a option of, you can share your work with your colleagues. You can add, you can create your teams, and just by a click of button, you can share your work with your colleague, and it generates a URL which can be simply used by your colleague, and you don't even log in. You don't even have to log into the AWS console. You simply use this URL, and directly you can go to SageMaker Studio. That will also save your time. So another important thing is SageMaker also supports the autopilot, right? So autopilot is, as you know, that many a times, especially for the regression and classification problems, uh, you might not have the AI ML capability in your team, right? Or you don't want to get your hands dirty with all the Python coding or whatever framework you are using, Tensor or whatever. But still, you would like to use SageMaker for your business uh, modeling, right? So for those kind of scenario, so it's a kind of like low code AutoML capability. You simply provide your tabular form of data to predict a regression or classification problem. And in the backend, it will take your data, and autopilot will automatically decide what is your target feature and what is the nature of the problem. It is regression or classification, and after that it will go and it will use different algorithms, and out of that different algorithm it will use different set of parameters, hyperparameters, and it will do run a lot of experiments in the backend, and the best model will be deployed automatically. So for you, autopilot, so think of all those business who don't want to hire a ML gurus or ML team but still want to go ahead and use SageMaker, then autopilot is the answer for them. They simply provide their data, and as an output, the model will be deployed for them automatically, and they can keep on calling the endpoint and get their data, get their inference out of the required data. So autopilot is also pre-built and supported under SageMaker. Yeah, so in the backend, so once you run your autopilot, it automatically trains and tune the model, and it also shows you all the different trials it did and what were the results of that trial, right? So if you look at the objective on the right hand side of this particular slide deck, it shows that okay, for model number one, the objective, the accuracy or whatever metrics they are tracking, let's see, they are tracking accuracy. So for first model, it is 92.06, for second is 92.02. And you can basically compare all these results and different which different outputs got generated by this model, and you can compare. So that is inbuilt in autopilot. And another good thing is that it also generates the Jupyter notebook for you, though you are not supposed to go and check it. But if somebody would like to see what happened in the backend, so it also generates those Jupyter notebook for you. You can go through the entire code. Even you can change your entire code if you want to do some editing. You are free to do so. So we also give you what went under the hood, and if you want to change that, you are welcome to do so. So that's a autopilot capability for you. Another important thing is security, right? So running the entire thing is one thing and achieving a best model is one thing, but you have to make sure that security is of paramount important, right? So SageMaker does provide all the inbuilt capability, like while creating your SageMaker Studio, you can run this entire thing in separate VPC, or you can encrypt your data while in transit or rest, right? And you can use all the different policies and security groups and other security mechanism which will make sure that only authenticated and rightly authorized people get access to those data and models and all the other components which you are going to use as part of this machine learning offering, right? And same thing goes for monitoring and auditability. Uh, Many times there are compliance requirements, especially in the industry like financial or health or all these sensitive industries, where for each and every prediction generated by your model need to be clarified to government or to the compliant body, that they might come and ask you, okay, your model generated this inference, tell me on what basis this model generated this inference, right? So inbuilt, you need to provide all the right decision making capability on which the prediction happened. So for that also we have different services which make sure that uh, uh, it tells you that what feature got more prominent over other feature and what were the criteria on which that particular inference got generated. So everything is inbuilt for you from compliance security perspective, and you don't need to worry about that. Now let's go the very first block. Once you know that we have studio in place now, so what we have to do in collect and prepare and training data. So the very first thing is the SageMaker ground truth. So as I told you, running your own labeling data mechanism can take months, right? So SageMaker Ground Truth is our offering which allows you to create all these labels up to 70% at less cost and at more speed, right? So internally, how it works is basically it has its own workflow, inbuilt workflow. It provides around 30 plus inbuilt workflows, and you can create your own. So you basically assign tasks to, initially you assign tasks to either your team or the third party labelers which we provide, or 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 you can hire external contractors also. So the initial part you need to make them label the data, and then you feed this label data to the internal machine learning model, which then automatically starts labeling the rest of the data. So that way you save cost and time and effort, right? So here you are seeing that initially all this data will be feed to those labelers, and later machine learning model, which is part of ground truth, will do the mapping, the labeling for you, and the same data then can be fed to machine learning training. And then that thing is fully managed, right? So in build it, as I told you, it has 30 plus labeling workflows. So based on your need, you can pick, and you can choose either your enterprise employees, or you can choose certified AWS contractors, right? So based on your choice, the initial set of labeling can be done, and you only pay based on the number of jobs and data you get label, right? So how it works, as I told you, the SageMaker ground truth takes, you take the raw data as input, you create a labeling job, and using either custom or inbuilt workflow. So the 30 plus workflow, if that suits your need, create that workflow. So that workflow is basically step by step path that, okay, the job will be assigned to person one, and these number of data will be assigned to person one, and then he will go and select all the right labeling, and then it will be feedback uh, uh, to the uh, to the original workflow. So the whole workflow is there, and that you can use, or you can create your own custom workflow, and then the labelers will do their job, and then this label data will be feed to internal machine learning model, which will then do the further labeling for rest of the data, and that's how you save and time and effort, right? So that was the ground truth. Using that, you can label your data. Now, the next thing after you have your data is data preparation. And rightly so, if you have worked on any ML project, you know that most of your time it goes on the data preparation, right? So under data preparation comes like cleaning and organizing the data, right? All those feature engineering and exploratory data analytics you do, one hot encoding label, encoding or cleansing your column, cleansing your rows, generating correlation and variance, and creating new features, removing columns or whatnot, right? So all these things falls under your data preparation, and for that we have there are multiple options for that also. The very easy one to use is a data wrangler, right? So think of data wrangler again, it's a managed service for you, and it is the fastest and easiest way to prepare data for machine learning, right? So how it works is that it's a visual editor. So let me show you, uh, probably let me show you in this slide. So this is the data wrangler, right? So here you can, what you are able to see that it's a visual editor where you are creating some sort of workflow. So uh, these workflow basically make sure that you are ingesting your data from different sources like S3 or Redshift or Athena, and all the supported stuff are there. So from there you ingest your data, and then there are pre-built, inbuilt transformers object and analysis object. Like typically you, as a part of your exploratory data analysis, you create a lot of table summaries, right, using pandas and other stuff, or you create a lot of uh, uh, graphs and pie charts, right, to comparison, and you run a lot of numpy or pandas transformer object, like removing a column or cleansing a column or creating a new feature, right? So there are many pre-built transformer objects which are embedded for you. You simply go and create this visual workflow. You ingest your data, you create a different transformation step, which I'll be showing you if time permits later. And then you create this entire data wrangler uh, workflow that will ingest your data, clean your data, and then you dump your data into the feature store or your S3. So this is the easiest way. So you select and query data, you clean and enrich your data based on all the transformers and analysis functions available to you. You visualize all those stuff in the same data wrangler visual editor, and then either you want to dump it into S3 on which training will happen, or If you want to dump it into the feature store, which is a data repository where you store all your single source of truth of the feature, so that all the different machine learning team take the same feature store, right? So you can dump it in the feature store, or you can dump it into the SageMaker pipeline. So there are different options depending on how you want to handle your end-to-end machine learning pipeline. So this is the data wrangler for you. Now, the second option of processing your data is SageMaker processing. So SageMaker processing, again, think of that. Suppose you have your own Python script or script to process your data, right? So you don't want to use data wrangler and don't want to use inbuilt function. You want to use your own script. So that is also very much doable. For that, you simply take your scripts and call this processing job. So think of processing job that in the backend, it will create a cluster of EC2 instance and it will run your scripts in all those EC2 instance. And then whatever processing script you have written, will be executed on your all your data. So for that, you can use SageMaker processing. And by the way, Data Wrangler also uses in the backend the same processing jobs. So you can go with the Data Wrangler. If not, you can also free to use the processing job. And the entire thing runs as a container, right? I told you everything is container behind the scene. So your script will run as part of your container, which you deployed across all the different EC2 script. Now, once you do feature engineering data preparation, uh, the result of that preparation is that you want to maintain a single source of truth for all your features, right? So suppose there are 10 different department, each department is doing its own ML pipeline. So many times they might end up doing the same stuff. They might generate the same feature store. So a lot of time and effort is getting wasted, right? And obviously one department doesn't know what other department is doing. So for that, to address more efficiency and to generate a single source of truth, this feature store is there. So all the different data on which you do cleansing and you create features will get stored into a single data repository. And you can even segregate different features under feature groups. Like suppose as one of the consumer of this feature store, I'm only interested in the marketing data. So you can create a feature group called marketing, and under that you will only put the marketing specific features like what is the job of the person, or does he own home or not, how many cars he got, or what all things meant for marketing. You can dump it under the marketing feature group. So that's how you need to think of a feature store as a as a single repository of all your features, from which you can either train your model, right, which will be seeing today, or at the time of generating the inference also, the endpoint will consult first about these features and then kind of like generate the inference. So it's a quite important feature. So as I told you, the challenges of maintaining different feature store is that different teams might generate a lot of duplication. The entire process might be slow, and there'll be no single source of truth. So to address that gap and issue and bring more effectiveness, the feature store has been introduced, and we'll be seeing this today. The next step is choose or bring your own machine learning model, right? So under this, you will see that there are different flavors. So if you look at this slide, the middle one is that obviously for training, you provide your data. Now, there are built-in algorithms. I think around 20 or 22 built-in algorithms are there. These are all the popular algorithms which are out there in the market, right? Uh, uh, like XGBoost or all the different popular one are already provided for you. If you want to use that, it's quite easy. You simply use that. If not, what AWS provides, it also provides some deep learning frameworks like MXNet, Gluon, TensorFlow, Keras, PyTorch, Chainer, and not only that, list is quite large now. So if you want to use these frameworks, if your use case is not getting satisfied with the built-in algorithms, then you use these deep learning frameworks, and you provide your training or inference script to this deep learning frameworks, and your script will run along with this framework in a container, right? Uh, the third option is if you don't want to use any of them, you are telling that no, I have already trained my model elsewhere. I simply want to bring my own model. You are most welcome. Bring your own model with an image which can be deployed as a container. So for choosing the algorithm also, you have a lot of options. You can use our built-in algorithms. You can use our deep learning frameworks which are embedded into our containers. You simply provide your script, or you can bring your own model, right? So this is quite a flexibility for you to choose your model. And these are some of the inbuilt algorithms I was talking about, right? So based on all the popular frameworks and popular algorithms out there, these are some of the uh, uh, pre-built or inbuilt algorithms like the k-means, PCA, sequence to sequence, and other. If you want to use, you are free to use that. Another critical part of the studio notebook, right? So you will see in today's this thing also. This is the studio notebook, right? And here you can see that right from this entire from this single studio notebook, you can write your entire end-to-end ML pipeline. Like I was telling you that uh, you can create your own training cluster. So look at this thing here. I am creating my own training cluster. So estimator is our object which gets resolved from the Python SageMaker SDK. So here you're just telling that, okay, how many number of which ML which EC2 instance you're required to create your training cluster, right? So in the backend, you need multiple EC2 instance on which training will happen. So here you're just providing the type of the instance, the count of the instance, and the output path where the model artifacts will be done, and the container. So which algorithm you want to use, that you already uploaded into a container, so that will get downloaded and the entire cluster will be created for you. So in this studio notebook, you are simply using SageMaker Python SDK and just a couple of lines of code. You are kind of like doing the entire training, and not only the training, the deployment of the model. And later you will see the hyperparameter tuner, right? So there is auto tuning also. Suppose I'll be talking about later, but in a single line, you are telling SageMaker that, okay, go and create multiple training clusters where I am providing you different hyperparameter ranges. So take the different permutation combination of this. So it's not permutation combination. There is again mathematics or different algorithms behind the scene, but it will do lot of automatic hyperparameter tuning for you, and it will come up with the best model for you. But here you are just writing one single line of code, right? So that's the beauty. And the entire thing you are doing into this SageMaker Studio notebook. So that helps you to build entire thing. It's a fast to set up, easy to collaborate, and you are maintaining everything from a single uh, pan of notebook, right? And then under setup, managing environments, and for training, we have uh, uh, different flavors. So uh, like you, at the time of training, you only get charged till the time your training happens. So if you look at this slide, let me explain how the training happens so that it will give you more clarity, right? So on the bottom left side, we have Amazon S3 where your training data is residing. On the bottom right hand side, you have your training image and your inference image. Your training image is like I told you that suppose if you are using our built-in algorithm, or if you are using our built-in framework, or if you are bringing your own model that need to be trained, or script that need to be trained, you go and upload it entire thing into a container image. So that image is there in SageMaker, right? So suppose for simplicity, you are using TensorFlow framework, right? So the moment you launch that two lines of code, right, which I showed you, that tells SageMaker that take different take these many number of EC2 instance of this type and create a cluster for you. So that moment, the top cluster will be created for you. The SageMaker training data will be copied from S3 to the cluster, and the training image also will be copied and it will run inside your container. So now you have your container running, you have your data into the cluster on which training need to happen. Now simply the training will happen. And once the training is finishes, the model artifacts will get again get stored into the S3. Now the model artifacts get stored into the S3, your cluster will be torn apart. Right? So suppose your training went for say 30 minutes. So after 30 minutes, the above cluster will be gone and you'll only get charged for that 30 minutes and your model artifacts will go and get stored into the S3. So that's the beauty that you only get charged for what you use. And on top of that, also there are many techniques to save the cost. Like if you are aware, within Amazon EC2, we have something called spot instances, right? So spot instances, think of spot instances. They are very cheap version of the EC2. The only catch is that these are uh, excess EC2 capacity left over in that region at that time, which is cheaply available to you. But the moment some other customer claims EC2 a new on-demand EC2 instance, that spot instance will be taken from you, right? But for you it will be quite cheaper. So if your training is a stateless in nature and can bear uh, uh, a loss of couple of nodes in a training cluster, uh, we can use spot instances, and that will give you a lot of cost effectiveness, right? So that is the another way to save cost from within AWS SageMaker. Other thing is the automatic model tuning, right? So I think I just showed you. So behind the scene, many times you run experiment and you try to give your own hyperparameters and trying to come up with your own good model of based on those different hyperparameters. But SageMaker also have this component called hyperparameter tuner, right? So let me show you. I was just trying to execute it before I started this session. So look at this hyperparameter tuner. So this is again a high level object provided by your SageMaker Python SDK. Now the beauty of this thing is that here also again you are writing one line of code. So what you are telling SageMaker that through this object, I am giving you range of my hyperparameters. If you look at this hyperparameter range, and here I am defining the hyperparameter range. So I am telling SageMaker that okay, for ETA, I'm take value between 0 to 1. For minimum child width, take this value, this range of value, and for other parameters, take this set of values. So I'm providing different range of different hyperparameters, and then I'm telling this object, the hyperparameter tuner object, that take all this combination, and in the backend also it uses some regression mechanism to come up with the best model. But let's not talk that right now. So this object will go through all the different permutation combination of all the different hyperparameters, and then it will come up with the best model for you. So this is automatic model tuning for you, right? And that's what I was discussing in this slide, that Amazon SageMaker has inbuilt model tuning capability. You simply define different range of different parameters and you feed that range or ranges to the hyperparameter tuner object, which in turn will create different clusters, different training models for you, and it will come up with the best model for you. So that is also inbuilt, and you saw this just one line of code. If you don't want to use hyperparameter tuner, if you want to run your experiments, you're free to do so. We also have another objects called experiments and trials, right? So these are like you can define your own hyperparameters and you can run your thousands of experiments. You can compare all those different experiments from the same SageMaker Studio, and the best model you can deploy automatically. And for each model which got generated out of this experiment, you can basically see what matrices were generated out of that model, and you can compare visually in the same SageMaker Studio of all those different experiments. So you can basically track all 1,000 experiments you ran to come up with the best model inside the SageMaker Studio. If you don't want to use the hyperparameter tuner, so that's another object which is available for you. And this is the comparison visual editor I was showing you, that the same stuff what we saw in the autopilot is for experiments. It shows all the matrices and the accuracy or all the matrices which are up to. It can be compared across all the different trials you run to come up with the best model, right? So this is the beauty of experiments. Another important thing is, now think of a scenario that you are running your, sometimes, training a model might even take hours, right? So think of a scenario that, and there are some problems like vanishing gradient or gradient boosting, which which can push your trainings into a totally wrong direction, right? It might not result anything, but it can keep on consuming your time, and you might not complete your training. So you need some indicator or some debugger to tell you that your training is going in the right direction or not, and if not, what went wrong. So you need some insights during the training, right? So that's how the debugger can help you, that it can automatically detect and analyze anomalies, and for those anomalies it can give you real-time visibility what went wrong into the model training. So how it happens that there are checkpoints during your training, and all your coefficients or other parameters which got generated at the time of training will keep on getting stored into the S3 as a tensor, right? And then on those tensor you can pretty much run your own monitoring tool or Athena or whatever works for you to go through it and check what went wrong. So this is a very good monitoring and reporting system, uh, uh, not only for your training, but if suppose your training is happening on a resource which is getting bottleneck, right? So suppose for your training you choose a uh, uh, lower threshold or lower capability EC2 instance, but your training require a higher capability. So your training will take indefinite time, right? So not only it provides you the insight into the data of the coefficients, but the resource bottleneck also can be alerted using debugger. So it really helps you from multiple front, from resource bottleneck perspective, from common problems like vanishing gradient, gradient boost. So automatically detects and provide inputs to you, so that you come to know that something is not working much early rather than much later, which will save you cost, effort, and energy, right? Because you will be charged till the time the training cluster will be running. But if debugger alerts you that something is going wrong, you'll immediately stop your train and start debugging into it, right? So that's how the debugger helps you. So this is the way of working. I told you that during the training, it captures and monitors profiles, training anomalies, and everything. It will write into the S3 as a tensor, and then out of that data from S3, you can pretty much run different mechanisms. Like if you want to use your visual insight, you can use Athena inside the Studio Notebook, or you can check the CloudWatch events. So different mechanisms are there to check all these things. So this is also available as an object. Again, you add couple of lines of code, and that's it. It's available for you. So that's the beauty, that in a single Studio Notebook, you are getting everything as different objects, and in the backend, it is doing all the heavy lifting for you. Last is the deployment part. So not only you need different flavor of deployment, like so currently I think one is the real-time endpoint deployment, another one is the batch deployment, right? So if you want to generate your inferences from for batch data, you can do that, or real time you can do that. I think last reinvent two more capabilities got added, like asynchronous invocation of your endpoint, and serverless endpoint. So think of a scenario that you want to generate a model prediction, but you don't want your deployment endpoint up and running always, as it will cost you. You only need to invoke your endpoint as and when it is needed. So you go serverless, right? And then even after deployment also, you need to keep on monitoring your model, right? If model is doing good, it is not degraded. So for all that purpose, we have model monitor. So let's see how the hosting works. Similar fashion, uh, uh, you simply write two lines of code, model.deploy, and you provide the number of EC2 instance, the type of EC2 instance, the roles required to create that cluster. The mechanism is here also same. So after the last training artifacts, the model artifacts now is sitting into S3. So the moment you call your deploy object into the Studio notebook, which gets resolved through the Python SageMaker SDK, the model artifacts will be taken from that S3 bucket, and your inference images will be downloaded from the ECR, Elastic registry, right? So you upload your image into the registry, Elastic Cloud registry, and it will be downloaded from there. So inference image will be downloaded, the model artifacts will be downloaded from S3, and then it will simply create the endpoint, right? And now it's up to you. So this endpoint will be keep on running if you have chosen the real-time endpoint. If you want to deploy it as a serverless endpoint, that is also supported. So you only get charged based on the number of time and the time of time you invoke your endpoint, but the mechanism is pretty much same. So this is how it looks like in the backend. So the endpoint you saw here, this green one, the endpoint. So this is under the hood of that endpoint, right? So basically you will get Elastic Load Balancer, and behind the scene auto scaling group will be there. So based on your workload, it can scale up and scale down if you are choosing the real-time endpoint. Otherwise, serverless endpoint is totally hidden for you. All the elasticity is managed for you. Here also, all the elasticity is managed for you, but here at least you define the maximum number of each instance you can put into behind the elastic load balancer. Yes, so some key points again, the auto scaling is inbuilt, and the low latency and high throughput is inbuilt as part of those endpoints. You can bring your own model, you can deploy your model behind those endpoints. It's not only that we support what we provide, no. If you have created your model, you free to deploy. So the Python SageMaker SDK provides all the high-level objects for you, which makes your life very easy, as I showed you, right? The model monitor is another one service which helps you to keep gauge on how the model is behaving, right? So based on that, so what will happen that at the time of training, it will create a benchmark that okay, and this was the last benchmark when the model was trained. Now, as and when the new inference data keeps on coming for that model to be predicted, it will take what output was generated by the model, and then it will compare that prediction to the benchmark data which got generated from the training. And based on that, it can compare that, okay, model quality is going down or it is still like in acceptable range or not. And the moment it goes down, you can get alerted, and as a best practice, you can again automate the retraining of your model, right? So using this model monitor, you can achieve that part. So let me show you a demo, and that will also help you. So as part of this demo, uh, let me show you. So this is where is S3? Yeah. So I have three data today basically. So scenario is that you have a bank who wants to make sure that What all people shall I reach out who has a potential to buy a term insurance from me, right? So if you look at this CSV data, it is basically contains all the information of all the different people on which the model will be trained, right? And it will contain information like what is their job, what is their marital status, their education, have they defaulted on any loan previously, do they contain any housing, do they have any previous loan, and all those stuff, right? So when they last contacted, under which campaign, and right, so all the different stuff are there. So on this data your model will be trained later, but this is the raw data. So now what we did, like we went into the studio ID. The very first thing we did, like we used the data wrangler, right? So under this data wrangler we have this immersion flow. So this is a predominantly simple flow, but what we did, very first thing we did, that we got this data. So S3 data is coming here. Now there are multiple inputs which are supported by data wrangler, like Athena, Redshift, and S3, and there are a couple of more. But in our case, because our data was in S3, so we put it from S3, right? So the very first step in this journey says the source. It is coming from S3, right? Now, once we ingest, so this is ingestion of the data. Second is you can add many other layers. So in this transform journey or transform step, I'm conducting multiple steps, right? So you go here and you simply create additional transform or create additional analysis. I have already created for you, so let me show you. So look at this step 2, the data types, right? So here it's showing all the data types of all the different data. If you want to change it, you are feel free to do so. This is the very first basic transformation thing which you can do. Now for a couple of other, I have added additional transformation and uh, analysis. So if we look at the first one, what I have done, if I go here, so I have added additional. Yeah, let me show you. So there are many pre-built transformer objects are available, right? So if I go here and add a new transformer, so add transformer, I'm not going to add, but in that step, see, these are all transformers which are pre-built available for you, right? So if you want to do one hot encoding or feature date time management, or group by, or handling outliers, handling missing data, managing columns, managing rows. So all those predominantly common transformers are already available. But if you want to use a custom one using either PySpark or Python or SQL, you can write your own script, right? So this is exactly what I did. So here I added a custom script, right? Which kind of like adding a couple of additional features, like one of the key feature I think which can be good for my model training is I'm creating a new column or new feature called not working. So I'm checking if this person is working or not, right? But this is just for example. You can write whatever custom script you want to add. So that I added as part of this transformer. And second thing, I drop a couple of columns. So the dropping column is already available as part of my transformer pre-built mechanism. So I'm removing, I think, 6 columns, right? So this is also part of pre-built transformer. And then I'm applying one hot encoding, and then again some custom transformer, again some additional transformer code. So using the combination of custom transformer plus the inbuilt transformer, I am deploying multiple transformation on the incoming data. And then from the same editor, the data wrangler editor, you can add analysis. So I already added couple of analysis. Let me show you. Okay. So like, okay, let me show you from here. If you go and add analysis like histogram, right? So you can select different categories and it against the target feature, you can compare which feature impacting more against the target feature, right? So yeah, here you can see where is my analysis. I create a couple of them. Okay, let me create now. So suppose if I want to cross check how job impacts against the target feature. So on x-axis, I will select job, right? So okay, I already cleaned this data. So let's say I already put the one hot label encoding. So that's why the job have been already created multiple columns. But you select specific uh, uh, feature against the analysis type which you selected here. You can see that you can generate the bias report of your model. It will generate a preview bias report. Based on that, you will understand, okay, my model is going to right direction or not. And then all those different analysis which are supported. So similar to the transformation object we saw, pre-built analytical types, analysis types are also available, right? So you can generate table summary. It will generate on the left hand side, it will generate the preview. So all the table summary of entire data will be shown here, right? If you want to generate scattered plot or so all these different features are pre-built available for you. Simply go and select as part of it. And then in the end, what you'll do, you can export. So once your data wrangler reaches the last step, uh, like what I did, I use the SageMaker feature store. So the entire thing will be dumped into the feature store on which the training will happen. But you can also put it as a Python code if you want to change it, something on top of it, or you simply want to feed this to a SageMaker pipeline that is also supported, or you simply want to dump this entire data after transformation, so that is also supported based on whatever you want to do. So in my case, I created a SageMaker feature store, this thing. And the moment I click on this uh, Jupyter notebook will be generated. So the beauty about it is that all the automation or the configuration part you did, it generates the Jupyter notebook, which will be visible to you. So here you can see that, okay, what happened? This particular uh, data wrangler in the end created a feature group, right? So this is the ID and the feature group name, and then what all different features are part of it. So everything which you saw in the data wrangler editor will be captured here in this uh, uh, SageMaker Studio notebook. And if you want to play around or change, you are free to do so. Now at this moment, our data is here in the feature store. So again, if you go here and if I select feature store, so the output of the feature store got got stored into the output of the data wrangler got stored into feature store. So this is my feature store group which got created, and under this group, these are all the features available, right? And these all features will be used as a part of SageMaker training, right? Which you'll be seeing. Now, so far we reached till the feature store, right? Now I created one SageMaker Studio notebook, and inside that I'm going to train my model, right? So what is happening? Let's go through it. So the very first thing I'll do that I'll import my SageMaker Python SDK, right? And I'll define the right roles and access and prefixes for my S3 bucket. I'll import all the libraries, then I'll get my data, right? So in this case, I am fetching my data from this feature group, right? So I am providing my name of my feature group, and from here, the data will be extracted for training, right? And the good thing is that you can also run Athena query on the feature store. So that's what exactly is shown here. So this feature store data now need to be turned into NumPy data frame, right? Because on that we are going to train our data. train our model. So this is changing of that part from feature store to data frame. And then we are splitting this entire data into three category: train, test, and validate, right? So typically how the machine learning model, as you all know, if you have worked on ML, this thing, that you train your data on one set and then you validate it against rest 5% or 10%, and then another test data on which the real testing happens. So that's how you come up with all those matrices and confusion matrix or whatever, depending on your the problem which you are trying to solve. So here we created three different data set. Now, yeah, and then all this data set now we again uploaded into S3 bucket, because once you create the training cluster, it takes data from S3 and couple of other storage, but as in this case, we are dumping everything into S3. Now, once so far we have through data wrangler, we clean our data, we dump into feature store, and from feature store again we post it into S3. Now the training part starts, right? So here you are able to see that I am using my inbuilt XGBoost inbuilt algorithm. So for that algorithm also, the container image is already available to SageMaker Python SDK. It simply calls the URI of that particular algorithm and the container gets resolved. It is now pointing to the ECR container. It it takes now that container and pass it to the SageMaker estimator object, right? So this object, I told you that you just write 2 lines of code and entire training cluster will be created for you. So here you provide this container, and then rest of this stuff, what role will be required by SageMaker to create this cluster, and then number of EC2 instance you want as part of this cluster, and the instance type and other parameters, the hyperparameters which you want to pass. Later you will see that either you want to run experiments or you want to use the hyperparameter tuning job, the auto tuning capability, right? But in this case, I'm simply passing a hard-coded hyperparameter, which obviously you don't do, but for timing purpose, I've shown this part. And you are simply calling xgb.fit, right? So this xgb.fit will simply create the cluster, which I showed you in the PPT. In the backend, it will create cluster for you. It will take data from S3. It will download that container image. It will train, and then the cluster will be gone for you. And the model artifacts will again go and sit into this S3 bucket, the output path. So I'm also telling my cluster that, okay, once you are done, dump your model artifact into output path, and you are done. You can get, you'll be gone. So this is how the training happens, and then the hosting. So once you pick your best model, you again simply call xgb.deploy. So again, this is getting resolved from the SageMaker Python SDK. And again, you are telling the number of EC2 instances you want to create cluster and which type. So it will go and deploy the endpoint. And by the way, if you go to the console, all these things will be visible to you. The one thing is the processing job. So processing job, I told you the data wrangler creates the processing job, right? So it tells you that from where it took the data and all the operation it ran. And also you for the hosted, you run 1 line of code. So if you go into the inference, you will see the endpoints. You can see that one endpoint got generated. And by the way, the same entire thing is available in the studio also. So like if I, so technically you should go and check everything in studio. So here, like if I go and go to endpoint, so you will see this endpoint is there. So this new endpoint got generated, and here you can check model quality. So if you have enabled uh, model monitor, which is again just one configuration parameter, while invoking your endpoint, the model monitor and data will be shown here. So the entire thing is kind of getting into one place. So you deploy your model, and then it will start working for you. Then I'm just predicting some of the data and checking the confusion metrics here. And the automatic model tuning part, I told you, I think the hyperparameter tuner object is there. You just provide the range of the hyperparameters for which you want to train, and in the backend, it will do all the heavy lifting for you. And as a result, you will simply come up with the best model. And just before this call, I was trying to, yeah, so see the hyperparameter deploy this uh, uh, model. So then I'm generating some prediction, right? So yeah, so this is what SageMaker is all about. So in a nutshell, in a single place, you can handle all the components which might take your time, effort, and money. And it's not only time, effort, and money. It provides you all the best practices which you can simply avail from the single studio. So that's about all the thing which I want to speak today. If you have any question, please feel free to unmute and ask. I hope you got it. Yeah, another thing I want to share. So if you are new to AWS, so I would recommend again, because SageMaker is sometimes it takes what I wanted to show you. Yeah. So I'll paste this link. So there is a Amazon SageMaker technical deep dive series around 17 videos, right? If you simply go through these videos also, right? So each video is around 13 to 15 minutes, right? But if you go through this, you'll get a lot of clarity, and predominantly what I told you are shown in a much deeper way because it's spread across 17 lectures. So I would recommend that if you are interested, go through this particular link. I'm just pasting on the chat, right? So just go through it. And if you have any question, please feel free to ask.
All right. Thank you so much, Hemant, for joining us today. We will upload the recorded workshop to our YouTube channel, and we will share any additional resources, including that YouTube playlist on our Discord.